Welcome back, Focus Learners. Think of your Cambridge mathematics exam like a high-stakes boxing match. To win, you need to float like a concept and sting like evidence. Jab, cross, hook. That is the rhythm of your answer combinations. Today, we are stepping into the ring to crack the code on one of the most foundational, heavily weighted, and let's be totally honest, sometimes deeply intimidating topics across the Cambridge syllabus. While the strategies we are discussing today apply across syllabus codes like 0580, 0606, 4024, 4037, and 4040, we are specifically targeting the heavyweight champion itself, the AS and A-level Mathematics 9709 syllabus. We're zeroing in on differentiation, specifically the derivative of x to the power of n and the infamous chain rule. To set the stage, let's look at a classic past paper question. We have two students taking this exam, Alex and Sam. Alex is the kind of student who overloads their answers with raw mathematical facts, just dumping numbers onto the page with absolutely zero analytical structure. Sam, on the other hand, rushes. Sam completely misses the specific command word requirements like show that or hence and just sprints to a final number. When they face a multi-stage calculation like differentiating y equals 3x squared plus 2 all to the power of 5, they both get obliterated by the examiner's red pen. If you find yourself getting lost in the middle of calculations exactly like that, you are in the perfect place to turn that confusion into guaranteed exam marks. I want to start our session with this stark, unavoidable warning straight from the Cambridge Senior Examiner reports. They stated, mastering differentiation, derivative of x to the power of n, chain rule is essential. This topic appears in every examination series. Let that really sink in for a sec. Every single series. There is absolutely no hiding from this. It's not a topic you can just skim over the night before and hope it doesn't show up on paper one. It is the absolute backbone of the entire assessment structure. When Alex and Sam failed that question earlier, it wasn't because they didn't know basic algebra. It's because they didn't understand the high stakes of structuring their differentiation. The expectations are incredibly high, but here's the fantastic news for us. Because this topic is so predictable, we can build a literal blueprint, a bulletproof strategy to conquer it every single time.
Okay, let's dive right into this. Here is our strategic syllabus for today's explainer, moving from core mathematical principles to top-secret examiner insights. First, we'll tackle the differentiation challenge and why it trips up so many candidates. Second, we'll build the procedural framework. Third, we are going to master securing method marks. Fourth, we'll uncover the top examiner warnings so you can avoid them. And finally, we'll lock in our ultimate answering system: deconstruct, solve, evaluate.
Let's move straight into Section 1, the differentiation challenge, core principles. Why do students like Alex and Sam find multi-stage analysis so intimidating? Let's break it down.
When you look at a complex chain rule question and your mind just completely goes blank, it's usually because Cambridge is targeting multiple cognitive domains all at once: knowledge, application, and analysis. It is never just about memorizing a formula. You have to break down the specific command words in the prompt. This requires a theoretical architecture built on precise definitions and causal relationships. This is where we apply our first major answering combination, the Peel framework: point, evidence, explanation, link. Yes, this works in mathematics too. Your point is identifying the correct rule, in this case, the chain rule. Your evidence is defining your inner and outer functions clearly on the page. Your explanation is the step-by-step differentiation. And your link is connecting that derived function back to the context of the question. The real secret sauce, straight from the examiners, is cross-topic integration. Top students don't treat differentiation in a vacuum. They seamlessly link it to finding equations of normals in coordinate geometry or calculating velocity from displacement. Before we continue, subscribe to our YouTube channel Ace the Exams at Ace the Exams IGSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 2, the procedural framework, systematizing success. This is where we turn abstract, floating math concepts into a reliable, standardized sequence. Let's systematize your success.
Listen closely. When you rely purely on your gut intuition to solve a complex math problem, you are opening the door to massive human error. We need a standardized sequence, a true mathematics success blueprint. Step 1, identify key elements. What variables are given? If your equation is y equals 4x minus 1, all cubed, you instantly identify the inner and outer functions. Step 2, apply relevant principles. You state you are deploying the chain rule. Step 3, execute with clear working. Step 4, verify your results. Step 5, present in the appropriate format. I want you to imagine a 60-second timer on your screen right now. If Alex and Sam were forced to rewrite their flawed answers using this exact 5-step blueprint, those red pen marks would instantly transform into green check marks. Practicing this exact checklist develops the professional analytical skills examiners are actually looking for, making your response automatic and saving your brain power for the tough arithmetic.
Which brings us to Section 3, Securing Method Marks. The process pays off. Let's shift our focus to the specific strategy of locking in points even when the math gets messy.
So the crucial point here is understanding that complex problem solving in Cambridge mathematics is not just a mad dash to a final numerical answer. It is a structured demonstration of your logical thinking. Process over perfection is your ultimate method mark strategy. In the 9079 syllabus, and really across all Cambridge math papers, marks are heavily awarded just for showing the correct procedure. Let's say you make a tiny silly arithmetic error early on. Maybe you multiply 3 by 2 and write 5. It happens. But if your conceptual understanding of the chain rule is clearly written out in your later steps, the examiners will award you method marks. Your step-by-step working is literally an insurance policy for your final grade. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions.
Academic benchmarks for this syllabus demand logical, structured reasoning. Let's jump into Challenge 1 of our interactive workshop, the data scan. Imagine a complex data table right in front of you. If you just scan it and throw down an answer that jumps around, skips steps, and only shows superficial breadth like Alex does, you will lose marks, even if the final number somehow ends up being correct. You have to extract the core trend with analytical depth. Prioritize analytical depth by explicitly writing down your exact steps for differentiating the inner and outer functions before ever attempting to link them together. Show the examiner exactly how your brain is working.
Let's pivot into the most valuable part of today's masterclass in Section 4, Top Examiner Warnings, Pitfalls to Avoid. These are direct, unfiltered insights from the Principal Examiner Reports.
We are going to build some anticipation here. By analyzing years of principal examiner reports, specifically covering the derivative of x to the n of n and the chain rule, we've identified the top 3 most common grade-destroying mistakes that students make. These show up in every single exam series, without fail. For Challenge 2 of our workshop, I want you to imagine a beautifully written but totally flawed math paragraph. Your job is to find the flaw before the examiner does. Let's make absolutely sure you aren't making one of these 3 massive errors on your big day.
Here they are. Number 1. Confusing cause and effect in multi-stage problems. Number 2. Forgetting to check format and presentation. You do all the intense, heavy-lifting math, but you leave the answer in a messy, unsimplified form that completely fails to match the specific command word requirements of the question. And number 3, answers that are not specific to the context given. If the question involves rates of change in a real-world physical scenario, your final presentation needs to reflect that physical context, not just exist as an abstract polynomial on the page. Now, for Challenge 3, speed writing. Next time you study, set a 30-second timer and force yourself to write one perfect Peel paragraph explaining your math step. It's a game changer.
And this brilliantly illustrates that number 1 warning, confusing mathematical cause versus mathematical effect. Let's bring back our boxing analogy. When applying the chain rule, differentiating the outside function, bringing down the power and subtracting 1, that is your jab. It's driven by the overall primary structure of the equation. Differentiating the inside function is your cross, a distinct secondary action, mathematical cause and effect. You must keep your inside and outside variables rigidly defined. If you don't, you risk applying them backwards, or worse, merging the operations together into one chaotic swing, completely distorting the causal mathematical relationship. You'll miss the target entirely, and the examiner will knock your score down.
We are bringing it all together now in Section 5. Deconstruct, solve, evaluate, the final masterclass. This is the ultimate problem-solving cycle that guarantees systematic analysis. If you want a cheat sheet recap graphic etched into your brain, this is it. This is the sequence for those massive, intimidating 8 to 10 mark questions at the end of your paper. Here are the 3 rules that guarantee top marks. Step 1. Deconstruct. This is command word decoding. Break the problem into logical steps, identify the given variables, and know exactly what the question is asking. Step 2. Solve systematically. Rigorously apply your PL framework and method mark strategy. Step 3. Evaluate. This is your time management matrix. Check your answer for reasonableness quickly. Does the calculated rate of change actually make sense in the context of the problem?
If a gradient is supposed to be negative based on the real-world scenario, does your final calculation actually reflect that boundary condition?
Highlight this crucial examiner alert as a final pro tip to secure maximum points. Examiner alert: candidates consistently confuse key terminology. Always define terms before using them in extended responses. Terminology absolutely matters, even in a numbers game like a math exam. If a question asks you to explain the physical significance of a stationary point found via differentiation, you must use the correct academic language. Defining your terms clearly demonstrates that highly rewarded analytical depth. Now, listen to me closely. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
So, what does this all mean for you? We've broken down the exact strategies for conquering differentiation: identify, apply, execute, verify, present. I challenge you right now to create a memory hack, a mnemonic, using the first letters of our framework, I, A, E, V, P, and write it on your formula sheet today so the sequence becomes second nature. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here. Remember, if the chain rule is fundamentally just a sequence of causal mathematical events, imagine what happens to your exam grade when you finally stop just memorizing the steps and start deeply understanding the cause. You've got this.